Okay, good day everyone. So in this video I'll be looking at differentiating inverse functions like sine inverse, cos inverse, and so let's get straight to it. So when we have a problem like, say, let's start from the basics. So if we have y equal sine inverse of x and we are asked to differentiate that, then the result we should get is, write it here, dy dx should be equal to 1 over square root of 1 minus x squared. Now that's what we should get. Now how we arrive at this result is like this. Okay, so initially we don't know what we get when we differentiate sine inverse, but we know what we would get when we differentiate sine, right? So what we can do is find the sine of both sides, because sine would be the opposite of sine inverse. So if we say sine y equal to, basically we would be saying sine of the sine inverse of x, right? And that would be sine y is equal to x, because the sine would undo the sine inverse, right? Okay, great. So we have sine y is equal to x. Now what we can do from here is find dx dy. Now dx dy would be equal to the cosine of y, right? Because when we differentiate sine we get cos. Since this is just y, then the derivative of sine y is cos y. So being that we have this, we can find dy dx by just reciprocating this fraction. If we reciprocate this side, we do the same here, or we can simply cross multiply. Okay, so dy dx would be equal to 1 over cos y. Now good, we found the value of dy dx. Great. So let's look at this now. Right, so let me just write down this identity. Sine squared a plus sine, that should be cos, plus cos squared b is equal to 1, right? And this identity is an identity we should learn and never forget, right? Sine squared of something plus cos squared of the plus cos squared of the same thing should be equal to 1, right? Good. Now we're going to use this identity to apply to this problem, because we're going to say, okay, let's square both sides here. So if we square both sides, we would have sine squared y, just change the marker, sine squared y is equal to x squared. Good. Now based on that, we can say that, okay, then if we should look at this formula, we can say that sine squared y is equal to 1 minus cos squared y, and that is equal to x squared. If we follow from this formula here, if you're still not clear, if we should make sine squared a the subject, right, then sine squared a would be equal to sine squared a would be equal to 1 minus cos squared a, right? So that's basically what we did here. We said that sine squared y would be equal to 1 minus cos squared y. Good. Now if we should let cos y be the subject, then we would have cos y, when we transpose, or cos squared y I should say, is equal to 1 minus x squared. Now in order to make cos squared y the subject, then we would have to find the square root of both sides if we were to make cos y be the subject. So if we root both sides, we would have cos y is equal to the square root of 1 minus x squared, right? Now being that we have an expression for cos y in terms of x, so we can then substitute that expression back here. So therefore we would have dy dx is equal to 1 over the square root of 1 minus x squared, and that's basically an explanation to how this result came about. Right. So we can look at the one for the cos inverse of x. It's similar. Finding it is similar. This time I will not write down the result first. I will work it out. You can always pause the video and try it on your own, and then look if you're doing the correct thing. So if we have y is equal to the cos inverse of x, then same procedure, we can apply the cosine to both sides. So we'd have cos y equal to x. Good, because we can't find the derivative of cos inverse of x, but we can find the derivative of cos y, right? So we cosine both sides, and once you find dx dy, then you can always reciprocate dx dy to get dy dx. So let's proceed. If you differentiate both sides, then you get negative sine y equal to dx dy, right? Dx dy. Now we can reciprocate, find dy dx. Let me put the dy dx on the left side here. So dy dx would be equal to 1 over negative sine y, and it's the same procedure following from this identity. Right, so if we should let cos squared a be the subject, then we would have cos squared a equal 1 minus sine squared a, right? And sorry, not cos squared, we should let sine squared be the subject. Oh, am I so off today? 1 minus cos squared a. Good. Now, instead that sine a is equal to the square root of 1 minus cos squared a. So we would apply this to the problem right here. dy by dx, and since this is a fraction, so the negative sign can go in the numerator, so you can have the negative one up here, right? And applying this, we would get sine y to be the square root of 1 minus cos squared y. Great. Now if we look back up here where we had cos y equal x, we can square both sides, and cos squared y would be equal to x squared, so therefore dy dx would be equal to negative 1 over the square root of 1 minus x squared. Good. So that's just how you get the standard results. And let me just do a question quickly. So if we had y equal the sine inverse of 3x, good. Now remember guys that this is not just x and it is 3x, so this basically needs you to apply the chain rule. So let's just do that. So dy dx, well, let me not do it shorthand. So if we should go the long route with the chain rule, then we would say let u equal 3x, therefore y would be equal to sine inverse of u. From here we can find du dx. du dx would be equal to 3, and from there dy du would be equal to 1 upon the square root of 1 minus u squared. Therefore dy dx should be equal to the product of du dx and dy du, so therefore that's 3 times 1 upon the square root of 1 minus u squared. But remember now that u is 3x, so therefore dy dx would be equal to 3 upon the square root of 1 minus 3x all squared. Good. And know that 3x all squared, that's 9x squared, so that's just equal to 3 upon the square root of 1 minus 9x squared. Great. So let's just clear the screen and try another problem. This time it will be with just change that and use cosine for now. cos inverse of, let's say we had x squared plus 2. Good. Now dy dx, I'm just going to do the shortcut method. So that would basically be -1 over the square root of 1 minus, and now in the standard result, let me write back this d dx of cos inverse of x, that is equal to -1 upon the square root of 1 minus x squared. Good. Now in this problem, our x would be x squared plus 2. Therefore, what comes here is x squared plus 2. Alright, and of course we'll have to multiply by the derivative of what's in the bracket here, and the derivative of what's in the bracket is just 2x, so we can multiply by the 2x. Therefore our dy dx should be -2x upon the square root of 1 minus x squared plus 2 all squared. Great. So that's basically it. The questions that come under this type will be similar. Just have to know that when it's not just x or just a single variable, like sine inverse of x or cos inverse of u or something like that, if it's nothing looking like that, then usually you would apply the chain rule. So for instance, you had this x squared there, or the cos inverse of sine x. If you had something crazy looking like that, then you would have to use the chain rule. Okay, so let's just clear the screen. Then let's look at the finding the derivative of tan inverse. So let's say we had y equal the tan inverse of x. It's basically the same procedure. You would tan both sides, so we would have tan y is equal to x. Now we would find dx dy. Dx dy is equal to sec squared y. If you remember from my previous video, when I did the derivatives of the trig function, if you haven't checked that out as yet, you can go and check that out. So the derivative of tan y is sec squared y. Now dy dx would just be the reciprocal of that, which is 1 upon sec squared y. Good. And what we can do is let me see, the identity that corresponds to this problem, I haven't looked at that as yet either, but I can write it here. So sec squared y, since we're dealing with y in this problem, would be equal to tan squared y plus 1. So therefore we can apply this to this problem, because if we look here, tan squared y, if we square both sides, tan squared y would be equal to x squared. So therefore we can replace tan squared y here with x squared and plug it down here. So dy by dx would be equal to 1 upon tan squared y plus 1, but tan squared y is equal to x squared, so therefore dy by dx is equal to 1 upon x squared plus 1. Good. So that is how that would be the result when you differentiate tan inverse x. You would get 1 upon x squared plus 1. So if you're making notes, then make note of this standard result. Dy dx is equal to ddx of tan inverse of x is equal to 1 upon x squared plus 1. Let me write this better. X squared plus 1. Good. So questions on this would be similar to those that we did previously with sine inverse and cos inverse. The only difference is the standard result here. You would still apply a chain rule if this were a 2x or 3x or x squared plus something. You would still apply a chain rule, but the procedure is basically the same when differentiating. Can do a quick problem. One quick problem, then end the video. I don't want the video to be too long, so say we had y is equal to the tan inverse of x squared. Good. Then dy dx would be equal to 1 upon 1 plus x squared squared. Good. Remember from the standard result here, tan inverse x, ddx of tan inverse x is simply 1 upon 1 plus x squared. But if we look in this problem, our x would be x squared, right? So we would plug x where x is in the formula here. That's what we did there, and x was being squared, so therefore the x squared will be squared. And don't forget, you have to multiply, since this is chain rule, you have to multiply by the derivative of what is in the bracket. Derivative of x squared is just 2x, therefore dy dx is equal to 2x upon 1 plus x to the 4th. And that's basically it. I'm going to end the video here, so ensure that you like the video if it helped you, or just like it, share it, subscribe, comment with any feedback. I'll see you in another video.